Welcome everybody, you're back. This time we're going to go over some terminology. I'm going to zip through this stuff fairly quick. Hopefully you've had at least a little bit of exposure to this stuff. And of course we're going to be going through a lot of this as the course goes on in more detail, and your textbooks cover some of this, and oftentimes they're in the glossary and things like that. So utilize all the tools you have available to you to understand these different terms. But these are all things that I'll be using constantly throughout the course, and things that are assumed that you understand as you read through the textbooks. So you are going to want to be familiar with pretty much all of these things, and then we'll be able to move forward with the material. So again, like I said, I'm going to go a little fast and probably not do a great job of covering every single one of these things and providing the best definitions out there, but I'm assuming you've had a little bit of exposure to some of it, or most of it. Okay. Oops, yeah, there you go. I already talked about that. These concepts should be a review, right? So if you're stuck, though, log into the Blackboard and our discussion forum or whatever e-learning system we're using this year, and go ahead and post up some questions about, say, correlation coefficient or experimental design or operational definitions, whatever the case may be. So don't hesitate to ask questions. It's this is terminology heavy field, and a lot of this stuff is very technical, so it's okay to ask questions. First things up, populations versus samples. Since we're going to be talking about research, we need to talk about these different things, because this is what we're often going to be focused on, at least in terms of doing research, but also interpreting that research. We need to know who it applies to and where it came from. So right off the bat, a population. The population is your person or group of people of interest, right? So a population doesn't just mean a population of a state, a city, a country, or the planet. It could mean a population of people in Spokane County that have been diagnosed with ADD, ADHD. Okay, so it can be very narrow like that, and that's okay. It's the people who the research study should apply to, right? So if somebody's done a study on ADD, ADHD kids, it probably isn't going to apply to a population of kids that are autistic. Okay, so we would focus on different populations in that sense. A sample. The sample is when we get a group of people from the population of interest. There's a whole bunch of different ways to get samples. We're going to talk about a few of those as in some coming lectures, and then your book covers some more, and there's probably another 37 different methods out there as well that we're not going to talk about. So there's tons of different methods to get these samples, but we always talk about the best one being a random sample. And that means that everyone in a particular population has an equal chance of being selected to participate in that study. Everyone. So think about that. Every kid in Spokane County that's been diagnosed with ADD, ADHD. If that's our population of interest, then we have to make sure each person in there has an equal chance of being selected for our study. Is that really how we do it? No. Why not? Because that's super hard. We would have to get every school district on board. We'd have to get every homeschool on board. We'd have to so on and so forth, and just be this exhaustive sort of thing. And we'll talk a little bit about that when we get into Shages, Cook, and Campbell, and talking about quasi-experimentation, about how we deal with random samples that aren't as random as what we think they are, and usually what it is, we just narrow our population, and we go the other direction with the population. Anyway, that's coming up, and we'll talk about that in a little bit. But let's see, what was I going to say? So what we often do is just a convenience sample. So we sample who's convenient to us, and sadly, in psychology in general, one of the most popular samples that we use in psychology is freshmen. Freshmen are our captive audience, so to speak. They're who we always have access to, so we tend to utilize a lot, or do a lot of research on them. The problem is they don't necessarily generalize to anyone but freshmen. So we have to worry about making sure we also get different populations. In school psych, this isn't as much of an issue, believe it or not. We do convenience samples, but they're very valuable convenience samples. We study one school district, or we study one school, and we study the fourth graders in that school. Well, you know what? That probably applies to other fourth graders in other schools, assuming things are similar, like socioeconomic status in general, you know, the region of the country that you're doing the work in, maybe the country you're doing the work in, and so on and so forth. But the convenience sample is just, it's easy to get these folks, right? So maybe the people at your school that you work at, and you do a study on them, that would be a convenience sample. Now, I'm hemming and hawing here in a bit, and it's because there's more to this story. The more to this story side of thing is that group research, as we're going to talk about primarily for this quarter, is originally the logic of group research, which originally in this random sampling and random assignment stuff, was actually based on farming analysis and how we can improve our farming techniques and do these different things with fertilizers and pesticides and so on and so forth. And when they did that, it guaranteed that every piece of wheat in the field had an opportunity to be selected, right? So we've gotten a little bit away from that, but there's plenty of folks out there that research how much of a problem that is for generalization and things like that. And it's not too much of a problem as long as we qualify our findings and do a lot of replications. So we'll come back to that stuff later. A census is when we can sample everybody from the population. That makes pretty much sense. In our field, that's not going to happen. Very rarely are you ever going to get a census of every third grader in the country. We do get censuses, the censuses, I don't know which way you say that. Censuses. I think it's censuses. I don't know. Doesn't matter. Anyway, we do get a census all the time in the sense of the standardized testing. You know, all the kids have to take those standardized tests, and everybody in the state has to pass it, right, or at least take it. So there's all those different things that we do, and essentially that's a census, so we can actually analyze that data and look at some interesting stuff. All right, another big one, reliability. All right, consistency. All right. Getting the same findings over and over and over again. If I do a study on direct instruction and I'm working with kids from Meade School District, and then I want to see if that works on kids in some school district in King County. So and if I get those same findings, I've demonstrated some reliability, right? If it works in both groups. So we have the consistency of findings, or the reliability of findings across the experiments. We also have another side of reliability here, and that's across assessments. So assuming that I give somebody an intelligence test today, I should probably get the same damn score tomorrow, right? Relatively speaking. So there should be this consistency of score across assessments, as long as you're assessing something that doesn't change quickly, right? Intelligence doesn't change super fast, so by assessing it every few weeks or something like that, you would expect those scores to be the same. So, and if the test does produce scores that are the same, we would say it is a reliable test. Right? Indirectly related to reliability is validity. Right? So we have external validity. This is the ability of the findings from your study to generalize to the real world. So will the results of your study be applicable outside of your study? Internal validity, probably the most, in my opinion, the most important type of validity there is. This is the ability of your experiment to detect an effect, if an effect is actually present. So in other words, does your independent variable, we'll talk about that in a minute, but does your independent variable cause some effect on people? If it does, did your experiment have the ability to detect it, or did you design your experiment so poorly that you can't detect it? Right? So internal validity is an important thing, and we'll talk a lot about that because in the education field we do have quite a few issues with internal validity. We often weaken internal validity in favor of external validity, and that's one of these two things fight with each other. Okay, believe it or not, that if you maximize internal validity, in other words, if you control for a whole bunch of stuff, you will inadvertently damage external validity. It's becoming too highly controlled, and it's not like the real world. And the converse is true as well, where if you maximize external validity and do your study out in the real world, then you're going to have all sorts of confounds that come into play in your experiment and damage internal validity. Face validity, this is often talked about with regard to assessments and things like that. Does the assessment make sense? Does it seem like, if it's an intelligence test, does it seem like it's assessing intelligence? Or is it assessing emotions? Or is it asking questions about emotions and things like that? So it's got to have some face validity to it. Construct validity is the thing that you're measuring, an actual thing. Does it exist in the real world, right? So if you're trying to measure intelligence, this is similar to face validity in a sense, but does the thing that does your survey or your tool, does that actually assess the construct that it's trying to assess? Right? Face validity is just how it looks on the surface. Does it seem like it's right? Construct validity is a little more technical, and you might actually, if you can directly measure a particular construct, you would correlate that into those two things together. Right? The findings from your study and the actual direct measurement. Okay? All validity requires reliability. You cannot have a valid measure that is not reliable. Because if your measure is constantly changing, right, whatever it's doing, so it's, in other words, it's not reliable, then you're probably not measuring what you intended to measure. In fact, I guarantee you're not, because it's changing, right, more than what it should. So you have an invalid measure. Right? So validity requires reliability, but not the other way around. You can have reliability without validity. In other words, I can have you step on a bathroom scale and say you weigh 137 inches. Actually, that doesn't make sense. 137 pounds, right? And okay, that's great. That's how much you weigh, but I could also use that as a measure of how tall you are. You will get the same score over and over again, but 137 pounds does not have any damn thing to do with how tall you are. At least, really, you know, obviously there's some relation there, but you get what I'm getting at. Okay? So you can have reliability without validity, but you cannot have validity without reliability. Quantitative versus qualitative measures. Now there's some argument in the field about which ones are right, which one's better, which one's not better, and so on and so forth, and I really don't want to get into all that because I'm biased, right? So I put my little thing up there that says I'm biased, right? My bias is towards quantitative measures. I would rather count something than guess at something, right? Because I'm a bit more of a hard scientist than most psychologists, right? So a quantitative measure, can I get a number for it? And for me, quantitative measures really fall along the lines of direct observation. Can I actually count something? There's other types of quantitative measures, but it tends to be on this continuum between qualitative and quantitative, with qualitative at one end and quantitative at another. And so the quantitative stuff is basically our hard numbers. Now, you might be thinking about, well, what about those surveys that say agree, disagree, strongly agree, that type of stuff? For me, sure, in a sense they're quantitative, but they're also qualitative because you're evaluating your opinion about something rather than directly assessing it. It's, in a sense, it's an indirect assessment because you're self-reporting. And anyway, there's problems with it. But qualitative is more about getting at the quality of some object or thing. What does the intelligence look like? How does the class feel, right? So did it have let's think about this class for an example. We could assess it in a qualitative way, saying, why don't you report to me what you felt like as you took the course? Don't tell me about the content, right? But just tell me about how did it feel? Did it seem interesting? You know, that's a qualitative type measure, right? A quantitative type measure for this class would be your scores on the test, or the questions that you asked. And I could even make those questions that you asked a qualitative thing, and I could judge the difficulty of the question that you asked or the accuracy, those types of things. My bias, once again, is towards quantitative measures. They tend to be easier to interpret, and people don't argue about quantitative measures. They'll argue ad nauseum about qualitative measures. And so I'm really in favor of the quantitative stuff. There are reasons for qualitative, and we'll get into that later on in the quarter, but a lot of times it has to do with different types of assessments that you're going to do, and you may have to pull some quantitative or qualitative stuff in there to help inform you about your quantitative data. So there's all sorts of reasons why you can use it, but I tend to focus more towards the quantitative stuff. Independent variables, these are the things that do the changing in a study. So in a study, if we are trying to manipulate something, then or when we manipulate something, we're manipulating the independent variable, right? So we tweak that. That's the thing we're interested in. We want to see, all right, what effect our IV, or our independent variable, has. Right? So if I want to see the effectiveness of direct instruction, then my independent variable is direct instruction. If I want to see the effectiveness of Khan Academy, then the Khan Academy is my independent variable, right? If I want to see the effectiveness of one lecture versus another lecture, then my independent variable is the lectures. Right? So those are the things that we're interested in finding out what they do. We do that by measuring dependent variables. Dependent variables depend on the independent variable. It's that simple. All right? These are the things we measure. So in this class, we have lots of dependent measures. I've got all your assessments. I've got the questions that you write, the answers that you post. I've got the procedures, or how long you take to complete the stuff on Khan Academy, how many of those you get right and get wrong, and how many videos you watched, how often you watched the videos, how long it took you to watch this one, and so on and so forth. Anyway, those are all some form of dependent variable. Right? It's the thing I'm measuring in a study. So you'll hear me just refer to both of these things as IVs and DVs. And so DV, dependent variable, IV, independent variable. Well, when we go into dependent variables, we need to know how we actually are going to do this measuring. Well, there's several different types of, several different categories of measurement. So let's look at those. The first one is a nominal. Now these are called scales of measurement, right? So the nominal scale of measurement is things that are mutually exclusive categories. In other words, we're just naming stuff, right? So eye color is nominal. Red, green, blue, whatever. Now, some people go, well, you can have green eyes and blue eyes. Sure, but that's a separate category. Somebody that has green eyes and blue eyes, they do not have brown eyes, right? So they fit in their own category, which is somebody that has multiple eye color, right? That's a nominal variable. We can't do much with that, by the way. It's very limited. Ethnicity is a nominal variable. Okay? Ordinal, as we go up in the scale, we improve what we can do with it and what we can learn from our numbers, right? So ordinal level data, the orders of the numbers mean something, right? So an example here is, we'll get to an example here in a moment, but the order of the number itself, I'm trying to think of a better way, what's up on the screen for crying out loud? Magnitude, right? So why am I struggling at this? I present this all the time. Anyway, ordinal level data has magnitude. In other words, that each data point can be bigger or smaller than the previous one, and that means something. Whereas in nominal data, blue eyes is not better than brown eyes isn't better than green eyes, or anything like that. Doesn't make any sense, right? But ordinal level data, it does. That there's something more than, it has the property of moreness is essentially what magnitude is. But it does not have a true 0 point, right? So for example, a good measure of a good example of an ordinal scale is a Likert type scale, right? So where you've got 1, 2, 3, 4, 5, 6, 7 or something like that, and the order means something, but there's no lack of, there's no true 0 point there, right? Then it doesn't matter what number you use. You could put a 0 in the middle and it still doesn't make any sense, right? So you could have -3 would be strongly disagree, and then -2 would be disagree, -1 would be somewhat disagree, and then 0 would be neither agree nor disagree, and then you go up for the agreement scales, right? But 0 doesn't mean you're lacking in agreement. It just means that it's just a number that you've applied to it. So it doesn't really have that 0 point. It's not like a lack of something, right? And no equal intervals. That's one of the things that is unique about, or not unique about, but is one of the problems with ordinal level data, is that there's no guarantee that the distance between a point on an ordinal level, on an ordinal scale, is the same as the distance between other points on the ordinal scale. I'm thinking about rank here, right? So like a team ranking. First place isn't twice as good as second place, and second place isn't twice as good as fourth place, that type of thing, right? The distance between those is completely arbitrary. So if you think about the agree-disagree, so who's to say that strongly agree, the difference between strongly agree and agree is the same as the difference between agree and somewhat agree? There's no guarantee that those distances in terms of concept are the same, but we kind of pretend they are, right? But that's ordinal level data. The order means something. Interval level data, and by the way, most psychology is at the ordinal level data. You guys will work quite a bit with interval level data because of the intelligence testing and things you do, right? It has magnitude, in other words, it has a property of moreness. It has equal intervals, right? But there's no absolute 0. A great example here is like a temperature scale. Anything other than Kelvin. Kelvin doesn't work for this example, but Celsius does, Fahrenheit does, right? So a 0, all right, on a Fahrenheit scale doesn't mean there's no temperature outside. It just means it's cold, all right? Okay, and really cold. But anyway, the distance between 0 degree and 1 degree and 1 degree and 2 degrees, those distances between them are the same, right? And the order of the numbers means something. So you have the magnitude, you have the equal intervals, you just don't have absolute 0. Okay? Ratio level data, this is equal intervals and a true 0 point and magnitude. So this is raw counts of behavior. You did do this or you did not do this. So if you did not engage in a violent act today, you did have a 0 level of it, right? So ratio level data is awesome. We don't get it very often in psychology unless you're doing just direct observation stuff. And more importantly here, the scale that you are using, right, determines what type of statistics, okay, you can use on the data. Ordinal or nominal level stuff, you got nothing, right? You got modes, and that's it. With interval level stuff, you've got means, medians, modes, you've got all those things, right? So ordinal level stuff, the mean is kind of odd, but sometimes we use it depending on how the data is structured, and we'll talk about that later on in the quarter. But ratio, you can kind of do everything you want. So depending on what type of data you have, it allows you to extract some information from it or not. Right, so if you've got the scale of measurement that's nominal, you're going to have very little information that you can actually get from that. But if you have a ratio level data, you've got some really cool info that you can pull. So we always try to maximize our scales of measurement, and we go for that interval or ratio level data. But oftentimes we're working in that ordinal level. Most quantitative stuff, most qualitative stuff is in the ordinal level, or ordinal or nominal. Most quantitative stuff is there's a little bit of overlap there. Primarily interval, but also ratio, and then every once in a while we get a little bit of ordinal level as well. So. All right. Oh, that kind of came up backwards. That's hilarious. I love it when I screw things up. Don't worry too much about that. We'll get to that second side here in a moment. Let's look at the different types of experimental designs that you should at least be familiar with on a cursory level. The first one is the descriptive research, right? Something that describes a phenomenon, and as we build up here, we're going to get to talking about the ability to do more things with the data, and do more things and make more inferences and be more confident in our findings, and that'll lead us into the next lecture when we talk about causal inference. All right, so descriptive research, we're talking about just simply describing a phenomenon. There's no explanation going on at all here. Right? So this would be like Jane Goodall type stuff. Okay? She wasn't trying to explain what the chimps were doing. She was just describing them. Right? There's plenty of examples of that throughout history. Right? Relational research. This is just correlations. Right? We're looking to relate patterns, not patterns, that's kind of cute, relate behavior patterns. Right? No, I'm kidding. No, relate behavior patterns. Right? Again, we're not trying to come up with any explanation, as we know that correlation does not equal causation. You can do some hypothesis testing with this, though. Right? So the hypothesis testing with relational research involves showing that two variables are not related to each other. Right? And if we can show that they're not related to each other, that's an important finding. Right? Quasi-experimental. Moving up another rung here, and this is what most of our course is going to be about. We're getting a little closer to being able to detect cause, and you can't really detect cause with it, but we're going to argue. I'll argue later on in the quarter about how you can try to detect cause. Right? So you're moving closer to being able to detect cause. There's usually manipulation here of some level, but you don't have random assignment to groups. Right? So when I say group problems, that's what I mean is that you don't have this random assignment, your groups may not be equal, and you got to deal with all sorts of things along those lines. So that damages our internal validity. Okay? This is typically very applied, though, and that's kind of the really nice thing about quasi-experimentation is that it allows you can do this stuff in the real world, and it gives you some pretty darn good results. And you've got to tweak with it a little bit, and you got to do some work to understand what it really means. But it's a lot better than just relational research or descriptive research. In experimental, or a couple of different ways to phrase this, I typically call it true experimental, and true experimental to me means randomized experimentation. So a fully randomized experiment. Okay? So where you've got random assignment to conditions, random selection from the population, and this is what allows you to detect cause. We're going to look less at experimental level design this quarter. We'll focus primarily on quasi and relational research. All right, confounds. Each one of those different levels of experimental design, the descriptive, the relational, the quasi, and experimental, they're all open to different confounds. Right? So confounds are the things that might explain the findings, right, that you have that are not your independent variable. Right? So we always assume that the independent variable is what caused our results, but if your experiment isn't designed very well, then it might be something else that's explaining it, and you didn't rule it out. Right? So you didn't do a good enough job of ruling it out. The fun part in designing and doing experiments and designing experiments is figuring out how you can rule out confounds. So we try to minimize these things. Right? So when we're designing an experiment, we try to minimize them in lots of different ways, and we'll talk about those ways. Right? We also search for them. We need to know they're there. So we seek them out, and we say, what could have been a confound? So, and this is what you're going to do a lot of in the future, is looking at, when you look at an experiment, you're going to say, ooh, what could have confounded this data? right? And the authors usually tell you in an experiment, but they like to minimize it. So you're going to kind of have to dig in a little further and see what confounds they may have. Right? We also call these things threats to validity. Confounds threaten your internal validity. They can also threaten construct validity, external validity, all those different things. But we typically think of them as a threat to internal validity. They threaten your ability to detect cause. So a poorly designed experiment has lower chances of detecting cause. In other words, it has more threats to validity. In other words, more confounds. Descriptive research, tons of confounds. Relational research, still tons of confounds, but not as many as in descriptive. Quasi-experimental results, research, now we're looking at fewer confounds, but still quite a few of them. In experimental, we tend to rule out a majority of confounds. But by doing that, we lose our applicability to the real world when we damage our external validity. So this stuff's a balancing act, and sometimes you're going to minimize one and damage another in the process, and then you try to control for that, and that causes damage to construct validity or whatever. And the whole point is that you're trying to balance this out and figure out how do you get the best experiment you can. But no experiment is perfect, so we just do what we can with what we got, and we move on. And speaking of moving on, we're done with this set of slides, so we will talk shortly in the future.